Recall that the process of esterification is you link three fatty acid molecules to a single glycerol backbone. Now, let's talk about the different chemical reactions of triacylglycerols. First, on hydrolysis. So the hydrolysis is just the reverse of the esterification process by which triacylglycerols are formed. So again, if you can still remember, triacylglycerols are formed through esterification, wherein you join three fatty acid molecules to a single glycerol molecule. So hydrolytic reaction of that. So hydrolysis requires the presence of an acid or a base. Now, under acidic conditions, that is, you have acids as your hydrolyzing agent and fats. Whereas under basic conditions, the hydrolysis products would be glycerols and fatty acid salts. Now, take a look at the difference between, wait a minute. Take a look at the difference between the products of hydrolysis when it uses acidic and basic solutions. Okay, so for conditions, for acidic solutions, the products would be the composing molecules or the building blocks of the triacylglycerols, which are, of course, the glycerol and the fatty acids. Now, under basic conditions, we can see here na lahi ang products of the hydrolysis. That is because in basic solutions, the products are glycerols and fatty acid salts. So in our body, the process of hydrolysis occurs during the process of digestion with the help of enzymes produced by the pancreas. So the hydrolysis occurring within our body follows a stepwise fashion. Okay, so it follows a step-by-step pattern. Okay, so remember, hydrolysis is where we remove one component from the other, meaning we remove the fatty acid component from the glycerol molecule. Now, removal, therefore, of all three fatty acids would result to a free molecule of glycerol. So recall that your triacylglycerol is composed of the fatty acid molecules. Okay, so if we are to break the linkage, linking the two, now our results would be three fatty acids and a molecule of glycerol, which is of course our building blocks for the triacylglycerols. Okay, now there is actually two types of hydrolysis. If all the fatty acid components, if all the three fatty acid components are cleaved from the glycerol molecule, then that is what we refer to as complete hydrolysis. Okay, so again, if atong i-remove all three fatty acid components in your triacylglycerols, that would be referred to as complete hydrolysis. Now, if one or if only one or two of the fatty acid molecules is being removed from your triacylglycerols, meaning na ay mabilin na fatty acid linked, which is still linked to your glycerol, then that is what we refer to as partial hydrolysis. So again, complete hydrolysis, all three fatty acid is removed, whereas in partial hydrolysis, one or two fatty acid molecules is removed from your triacylglycerols. So as you can see in this illustration right here, you can observe na katong ato ang water byproduct ganina, if you can recall, esterification would result to the formation of water byproduct. Remember? So as you can see from here, it seems like the water byproduct, our H2O, is being added back into our structure as indicated by these arrows right here. Okay, so there is an addition of a water molecule. So as a result, your glycerol would regain its three hydrogens back, whereas your fatty acid chain, specifically the carb carboxylic acid part, this one, this C double bonded to O and then a single bond to oxygen, would resume also or would regain also its OH that it originally lost during the esterification process. So this one, it regained its OH group, thereby completing the carboxylic acid end of your fatty acid. So as a result of your hydrolysis, you have a glycerol molecule, this part highlighted by pink, and then this one, two, three fatty acid molecules. So just remember the difference between complete and partial hydrolysis. So next reaction that is involving triacylglycerols is on saponification. So what is saponification? So saponification is kind of the same. Medyo pareho ra siya to that of hydrolysis. The difference lang is that this kind of hydrolysis uses basic solution. Now recall that the previous hydrolysis uses acidic solutions or is under acidic conditions, whereas saponification is under basic conditions. Now, if we are using basic solutions to hydrolyze our triacylglycerol, the products would actually be different. Now, the products for the saponification would be fatty acids and glycerol salts. Or rather, this should have been not fatty acid and glycerol salts, but glycerol and fatty acid salts. Okay, that one. So that would be the products for the saponification. Glycerol molecule and fatty acid salts. Now, this first equation right here, if you can recall, this is the one for hydrolysis under acidic conditions, because you have here the fats or oils plus three molecules of water would result to the formation of three fatty acids and the glycerol. Whereas if you are to add basic solutions, like for example this one right here, the NaOH, to three fatty acids, that would result to the formation of three fatty acid salts. So that would be the difference of saponification to that of hydrolysis. So saponification is actually the process of how we make soap. So for we would subject, for example, plant oils to saponification, and then the product of that would be soaps. So the fatty acid salts produced in saponification is actually made as soaps. So just remember the difference between hydrolysis using acidic conditions or acidic solutions and saponification, which is just hydrolysis in basic solutions or using basic solutions. Okay, so this one right here shows the products, the fatty acid salts produced in saponification. So the normal carboxylic acid looks like this, if you can recall. So we have the carboxylic acid, the COOH, and then the R, which is your chain of carbons in your fatty acid chain. Now, for carboxylic acid salt, as you can see, instead of having an H to your oxygen molecule right here, in replace of that is a positively charged sodium. Okay, so this is now the structure for your carboxylic salt. So again, this is the products of saponification, carboxylic acid salts. Now, the third chemical reaction of triacylglycerols is what we call hydrogenation. So from its very name, hydrogenation is just adding hydrogen atoms to our triacylglycerols. So this involves addition of hydrogen across the carbon-to-carbon multiple bonds, which increases the degree of saturation. So many food products are produced by partial hydrogenation of oils and fats. So as in the case of peanut oil, hydrogenation of peanut oil would produce peanut butter, whereas hydrogenation of liquid plant oil would produce margarine. Okay, so this illustrates the process of hydrogenation. So as you can see from here, the double bonds are lost because hydrogen atoms are added to the carbons right here possessing these double bonds. So by addition of hydrogen atoms, the double bonds are lost, resulting to the hydrogenated product. So as in this example, you can see that the double bonds in all the three fatty acids are lost. That is again because of the addition of hydrogen atoms through hydrogenation. Now, the thing about adding hydrogen for or two different oils and fats is that it increases its degree of saturation, thereby also increasing its melting point. So that is the result why liquid plant oils, for example, when hydrogenated, would become margarine, which is usually solid at room temperature. Now, the last reaction of triacylglycerols is what we refer to as oxidation. So, oxidation, as in hydrogenation, is just an addition of oxygen to the different double bonds contained in the triacylglycerols. Now, in oxidation, the double bonds in the triacylglycerols are subject to oxidation with oxygen as our oxidizing agent. Now, the thing about oxidation is that if if in hydrogenation, the addition of hydrogen would just add hydrogen atoms to the carbon that is originally double bonded, and then as a result of that, the double bond would be gone and will be converted to a single bond. In oxygenation, adding oxygen would would totally break the bond between these carbon molecules. Okay? So as it is said right here, oxidation would lead to the breakage of the double bond between the two carbon atoms that produces both aldehyde and carboxylic acid products. So say for example, you have this chain. of carbons in your fatty acid. Say for example, you have this one, and then you have here a double bond. Okay, so you have here a double bond. Now, if we subject this to oxidation, what happens is that the 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 bond would totally break. Then you have here an oxygen. Okay, so as you can see, the bond between them is totally um, cleaved, meaning naputol gyud siya totally, and would now produce both aldehyde and carboxylic acid products. So in this illustration, we can see right here that through oxidation, the double bond is broken down. Okay. And further oxidation of this would result to these products, the short chain aldehydes and short chain carboxylic acids. Now, the thing about these products, these short chain aldehydes and short chain carboxylic acids, is that they have this not so pleasant odors, okay? Not so pleasant taste, not so pleasant appearance, and fats and oils that have been or have undergone oxidation are said to be rancid. So in Bisaya pamasyag napanos, okay? So fats and oils that are subject to oxidation are said to be rancid. That is, they possess objectionable or a not very pleasant or not pleasant odors and tastes and appearance. Okay, so that happens as a product of oxidations. Now, to avoid this unwanted oxidation process, antioxidants are being added as preservatives. Okay, so to avoid the oxidation, to avoid the production of the short chain aldehydes and short chain carboxylic acids, antioxidants are being added to the fats and oils. So examples of these antioxidants are the vitamin C and vitamin E, which are naturally occurring antioxidant. Now, the thing about this is that imbis nga ang food ang ma-oxidize, the one that is being oxidized instead is these antioxidants. So meaning the food is being kept untouched by oxygen and therefore is not being subject to oxidation. And furthermore, they won't become rancid. Okay, so this is what happens, or this is what is usually done when with people selling fats and oils. So they would normally add antioxidants so that their products would not become rancid, because again, instead of oxidizing the product itself or the food itself, the one being oxidized is the antioxidants na gi-add dito sa atuang product. So as a result, your fats and oils would be preserved. Okay. Now, oxidation is what happens when people sweat and they develop an unpleasant odor, because as we all know, sweat contains oils, correct? Now these oils, when being subject or when subjected to oxidation, would result to the formation of these short chain aldehydes and short chain carboxylic acid. That is why when a person sweats, pag sington ang tao, and then in this sweat, this contains oils. So when these oils present in the sweat is oxidized, that person will now develop an unpleasant odor. Okay, so this is usually present, or this is common among people who sweat too much. They develop a distinct unpleasant odor. So that is again because of the oxidation of the oils present in the sweat.